In this video, I'm going to talk about how to find the area of a kite, right? Earlier in the chapter, we've looked at problems where you're taking a shape and you're breaking it up into pieces, okay? So for example, a kite could be broken up into right triangles using diagonals. Remember, one diagonal gets bisected, the other one usually doesn't. It's possible, if they told you that this was 3 and that was 4 and this was 6 or something like that, it's possible you could just find the areas of those triangles and you could just add them up and have the area of an entire kite. One of the other possibilities is that you would be given information about the diagonals, and that's what we have here. So we're told that AC has a length of 8, we're told that BD has a length of 6, okay? We do know that BD is getting bisected, so that's going to be 3 and that's going to be 3. We don't know how the 8's getting broken up, okay? It's not likely going to be 4 and 4. I don't know if I can break it up into 6 and 2 or 5 and 3 and get the same answer every time. That's somewhat open to question, okay? So here's what I'm going to do. I realized that ABC by itself is a triangle, okay? And I know how to find the areas of triangles. So I'm going to find the area of this upper triangle up here, okay? This whole base, no matter how it's broken up, has a length of 8. Okay? So if I look at triangle ABC is really a triangle that has a height of 3 and a base of 8. Well, I can find that area and I can just double that to get the area of the whole kite. Okay? So the area of a triangle is half the base times the height. The base is 8. The height is 3. Okay? Half of 24 is 12. That would be the area of one of these triangles. And then I could double it, and the entire area would be 24 square units. Okay, so we could do that. Okay, so 24 square units for the whole thing. I'd like to try to turn this into a formula. Okay, so I'm going to come back and I'm going to do this with variables. And if you can do a process with variables, you should be able to actually make a formula. It should be the same process every time, just the numbers potentially can change. So I'm going to call AC diagonal 1. I'm going to call BD diagonal 2. Okay, we're going to come back here. So we're going to call this D1. Okay, diagonal 2 is getting broken up into parts. So this is going to be 1/2 of diagonal 2. And this is going to be 1/2 of diagonal 2. And the two parts add up to just D2. Okay, so I'm going to just look at this upper triangle here. I have a base representation, D1. I have a height representation, 1/2 D2. So the height's going to be 1/2 D2. The base is going to be D1. Okay, the area of a triangle is 1/2 the base times the height. Okay, if we multiply that together, this is all being multiplied, the order doesn't matter according to the commutative property, we end up getting 1/4 D1 times D2. But remember, that's not the area of the entire kite, okay? That's just the area of this half of the kite. I've got to double it because I've got this upper half that has an area of 1/4 D1 D2, and the bottom half also has an area of 1/4 D1 D2, okay? So I'm going to take that 1/4 D1 D2 and I'm going to double it, okay? What happens if you double a 4th? You get 2/4, which is 1/2, all right? So that's our final formula. It turns out that the area of a kite is 1/2 the product of the diagonals, okay? It's a very simple formula. If they just give you diagonal lengths, multiply them together, take half, okay? So the area formula here, and again, you can break it up into shapes just depending on what they give you. But if they give you diagonal lengths, the area is 1/2 the product of the diagonals. That's all you have to do, all right? So if we go back to our original example, remember that AC had a length of 8, I think, and BD had a length of 6. So the area would be 1/2, one diagonal, times the other diagonal. And if you remember, it was 24 square units. Okay, our formula works, gives us the same answer that we had earlier. Okay, very simple formula to work with. Okay, one other thing they're going to throw in here. I think that the section says something about areas of kites and related figures. One of the related figures they're talking about is the rhombus. Okay, remember that a rhombus is technically a kite. It's got two congruent sides, and it's got two other adjacent congruent sides, okay? It just happens it's a kite that has 4 congruent sides. But a rhombus is considered to be a kite, okay? So for example, if I tell you that the perimeter is 40, and I tell you that one of the diagonal lengths is, let's say one diagonal length is 6. No, let's do 12, okay? Something like that. Well, all the sides are even, so all side lengths would be 10. And then I can draw my 2 diagonals in, okay? Remember, rhombuses break up into 4 congruent right triangles, okay? The diagonals bisect each other, and they're perpendicular, okay? So we've got a side length of 10, we've got a diagonal length of 12, it's getting bisected, we get a 6 and a 6, okay? Notice, you've got a little right triangle there. You could use the Pythagorean theorem to find this length along here, or you might notice it's a little 3, 4, 5 right triangle, okay? So 3, 4, 5, that would be 6, 8, 10, and we've got an 8 and 8 there, okay? So, the area, it is a kite. It's half the product of the diagonals, okay? One diagonal is 12, the other diagonal is 16, okay? I think that gives me an area of 96 square units. Let's see. Half of 16 is 8, 8 times 12 is 96. Half of 12 is 6, 6 times 16 is 96. Yeah, either one of those should work, okay? So 96 square units. Of course, you could find the area of one of these little triangles. You've got a base and a height there. Half the base times the height would give you 24, 24, 24, 24, which is also going to add up to 96, okay? One thing to remember about a rhombus is also a parallelogram, okay? So you can also use the parallelogram area formula. Remember, the area of a parallelogram is equal to the length of the base times the height. Not a base times a side length, a base times a height, okay? The height would be going through something kind of like that, okay? And in this particular problem, we don't have that information. So you'll have to decide, do I have information about the diagonals? If so, use the kite diagonal formula. Do I have a base and a height? In that case, use the parallelogram formula. The rhombuses are kind of special because they break up into shapes and they can be classified into a couple of different categories. And as a result, whatever information you have, use the formula that matches it, okay? By the way, let's remember something here. Remember the area was 96, okay? Not 9H, sorry, 96. The area is equal to the base times the height, okay? We should get the same area regardless of which approach we use. So let's say you wanted to know what that height was. Let me maybe draw a little more clear picture here. We know the area is supposed to be 96, right? This side length is 10. We know the height's right there, we just don't know what it is. Well, guess what? The area doesn't change just because I don't know what the diagonals are. The area's still got to be 96. I've got to take 10 times the height, and I've got to get 96. So you can actually fill the area that you knew from this formula into the other version of the formula, and you should get the same thing. So you can work backwards. The base is 10. We want to know what the height is. And you can divide both sides by 10, and you'll find out that the height needs to be 9.6 for that rhombus, okay? I think we saw an example of this with a triangle problem back in a previous video. Your book likes this idea. Find the area using one approach, and then see if you can use a different approach to work backwards and find some other missing dimension. So with triangles, we were using different bases and different altitudes and getting the same area. Here, because a rhombus is both a parallelogram and a kite, we were able to use 2 different formulas. The area should work out to be the same. So find the area with the information you have, and then work backwards for the formula that involves the thing that you didn't have, which in this case was the height. So some interesting stuff there. Hopefully that's helpful for section 11.